Hello class of 2018. In this one, we're looking at using the normal approximation to the binomial distribution when it's appropriate. So we'll discuss what conditions make it appropriate to use the approximation. So let's have a look at these various distribution graphs. So here n is 10, p is 0.2, here n is 10, p is 0.5, and here n is 10, p is 0.8. You can see that there are only a few columns, if you like, because n is small. And you can see over here n is 20, and the shapes are roughly similar. So if it's 0.5 for a probability, it's quite symmetric about the mean, which is 50. And if it's 0.8, it's skewed to the right, which is, I always think about this, which is negatively skewed. And if it's 0.2, which is closer to 0, it gets skewed to the left, which is called positively skewed. If n is sufficiently large, then the binomial random variable starts to look very much like a normal distribution, and we can use the mean, which is np, where n is the number of trials from the binomial and p is the probability of success in the binomial. Standard deviation of this normal curve would be sigma, which is n times p times 1 minus p, which is number of trials, probability of success, and probability of failure. But there is actually a typo in here. It's actually the square root of all of that, which comes in later. So what comes in handy is that if both n times p are greater than 5 and n times p times q are also greater than 5, then you know you can use the normal distribution satisfactorily. So here we have a case where you can use the normal approximation. Here's my hint, that's the approximate word there. And so if we set this up like a binomial, n is 1,000. The probability of success is 0.3, and x is the event that a person is in favor of the new freeway. So you're asked to find the approximate probability that between 270 and 330 people are in favor. So what you can do, because you're finding the approximate probability, is you can approximate it to the normal distribution, where the mean is n times p, which is 0.3 times 1,000, which is 300. And the standard deviation, is the square root of n times p times 1 minus p. So that's 300 from before times 0.7, taking the square root of all that, which is 14.4914. So from before, we have a mean of 300 and a standard deviation of 14.4914. And so if you use our cumulative probability distribution for the normal distribution, then we will get an answer of 0.961566. Now you could have a more accurate approximation by going halfway, because we only take, for the binomial distribution, we don't include the 270 person. So that's the center of the bar. So we need to actually take to the inner side of the bar. So 270, and then that's the bar 330 right there. So that line there is actually 270.5, and this line here is actually 329.5. So if we find that probability, that will equal 0. 0.958219. And if we use the actual binomial with those numbers, where we have the upper bound, sorry, the lower bound 271, the upper at 329, what do we get? We get that the probability of going from 271 to x to 329 is actually 0.958292. So you can see that the approximations are very, very close.